new math. We're just looking at some situations where logs and exponential equations show up, because logs especially have a lot of different applications. The things that I'm showing you today, I don't expect you to memorize, so I would give you any formulas on any questions I were to put on a test or a quiz. We're just looking at some of these scenarios. So one situation that you guys have all probably heard of, you found pH, right? You talked about pH in your science classes. Everyone except Zach. Zach is just lost. You guys can help him out later. But everyone else has heard of pH before. Well, it's actually a log equation. It's the opposite of the log of H3O+, or the hydronium ion concentration. Basically, I would give you this formula. We're just going to use it to solve a couple problems, right? So if I look at this one, find the pH of a solution if the H3O+ is 2.5 times 10 to the negative 4. All right, so my equation, and I put it at the top, right, in your box at the top, the pH is the opposite of the log of the H3O+. So you are literally just putting this into your calculator. Negative log 2.5 times 10 to the negative 4. What?
I said, you kind of made that look way more scary than
Trying to make you worry. I told you, it's no new math. Just easy. pH, we usually round to 1 decimal place. So what do you get? Pick up a calculator, look. 3.6. Yeah, you can do more decimal places. We really only have to have 1.
Yeah.
All right. Part B.
Oh, there you go.
Find the hydronium ion concentration of a solution with a pH of 7.1. So using my formula that's at the top of your paper, this time I gave you the H3O+. We're solving for the pH. Oh, sorry, I said that backwards. I gave you the pH. We're solving for the other. So my pH is 7.1 equals the opposite of the log my H3O+. All right, but this isn't a very complicated equation to solve. What would we do with the negative? How would I get rid of it? Let's just divide it. Okay, you were solving log equations last night. If there is a log on one side, how do I get rid of it? Yeah. What is my base if I don't have it written? So I get 10 to the negative 7.1 equals the H3O+. You can type this in your calculator. You're not going to get a super nice answer. So if you type that in, you see it gives you like 7.94, so 7.9. And then it says E negative 8. That means times 10 to the negative 8. Technically, either of these is correct, but the second one is how it's usually written. Any questions about pH? Okay, so your Math Excel tonight has several of those problems. Second situation I want to look at is exponential growth and decay. This is talking about how substances change over time. All right, so the formula, you have to write this one in your box at the top. The A of t, the amount present at a given time, is equal to A sub 0 e to the kt. All right, in this, a of t is the ending amount. A sub 0 is beginning amount. K is some constant value. And t is the time that has passed. If your k is greater than 0, it's growth. You're gaining over time. If it's less than 0, you have decay. You have less as time goes on. Again, I wouldn't make you memorize this formula. I would give it to you. We just have to be able to use it. So let's look at example 2 here. If 800 grams of a radioactive substance are present initially, and 2.5 years later, only 400 grams remain, how much of the substance will be present after 4 years? So, my formula, A of t equals A sub 0 e to the kt. We have to find k. Now, I gave you some information here. What would the 800 represent? That's the A sub 0. That's how much we started with, right? This information right here is essentially an ordered pair, and we're going to use that to find our constant. So, what I currently know is I started with 800. To get my actual equation, we have to find k. That's our goal here. And then we could calculate the amount at any given time. So we're going to use this ordered pair to plug in. In 2.5 years, 400 grams remain. That's sometimes called the half-life, the length of time until you have half of what you started with. So if 400 remain, that's the amount I have. And that took 2.5 years. Okay, so let's solve for k. If I divide over my 800, how do we solve this equation? This is something I would have put on your homework yesterday. It's an exponential. What do we add to each side? Log. And since it's an e, let's do a natural log.
Where'd you divide by?
800. So the benefit of that, the 2.5k comes down. We have a natural log of e, but we know the natural log and an e just cancel, so I could even drop that. So now we just have to do what? Divide the 2.5. And let's go ahead and put that in our calculator. So natural log of 1/2 divided by 2.5. If I go to 4 decimal places, that's negative 2.77. That's the constant. That part doesn't change. So now I actually have my exponential. In this case, it is decay. And since my k is negative, I have less as time goes on. So I use all the information given so that I could find my k, and now I know the true equation. Are there any questions there? So then, coming back to the problem, it says how much will be present after 4 years. So what am I going to do with that 4? put it in my calculator. And I get 263.86 grams. Any questions? I want you to read B. I'm going to give you just a couple minutes and see how far you can get before I help you. All right, so what is my A sub 0? Good. All right, so we need to find K. So we're going to use this information. In 3 years, 300 grams remain. So the amount that I have is 300. And my time was 3. So if I divide by 600, I get 1/2. And then what do you do? So 3K comes down, the natural log of E would drop. So we divide by 3. And we get K to be negative 0.2310. You guys agree with that? So my formula is 600 E to negative 0.2310 T. So I want to know how much will be present after 6 years. Plug that in. And I get 150.04, so about 150 grams. Do you guys get that? We agree? Do we need more problems like this? Okay. Some other situations, interest. We've talked about compound interest before, right? You'll notice those boxes at the top of your paper. There is a box where I put the interest formulas again, because I never made you memorize them. I always gave them to you. So I want to ask a couple interest questions. How long will it take for the money in an account that's compounded continuously? When you see continuously, what does that mean?
Every day.
Well, even more.
For a long period of time.
Which formula do we use?
Usually
Okay.
Hard.
What does the 5.75 represent?
Right.
Good. And we have to divide it by 100, right? So 0.0575. I didn't give you the starting amount or ending amount, but I said I wanted it to double. So if I start with $10, how much would I end with?
20.
Okay, so if I plug that stuff in, and I want to solve for t, what would we have to do? Divide the 10. And then what do we add? Exponent comes down. And we have a natural log of e, which just cancels out, right? That's 1. So divide. So I get 12.05 years. Is that okay?
Mhm.
I want you to take a couple minutes and try to at least set up the next one. So if you don't want interest formula, do we use? Okay, what does the 1,000 represent? Starting amount, so my P is 1,000. My rate is compounded quarterly, so that means, and if it grows to 2,700, that is my, okay. So if we plug in A equals P plus 0.02 to the 4t power. All right, did we get there? What would I do with that 1,000? Divide it over and we get? Okay. Now, if we did the 1 plus 0.02 divided by 4, what's that give us? Now what do we have to do with the log? There's not an E, so you could do regular log. Can I go ahead and break down my exponent? So if I'm trying to find t, I have to divide by the 4 log 1.005. So we get t to be you guys get 49.79, and that would be my time in years. Going to take quite a while. All right. Any questions about any of those applications? All right. The final thing I want to talk about is what's called the change of base formula. And this is what allows us to take a log and change it to any base that we want. Most likely, we will be changing it to a base 10 or a base E because those are the two buttons we have on our calculator. To do that, you do log of the big number divided by log of the small number, essentially. So, for instance, if I gave you this, if I want to put this in my calculator, I can't, as it's written right now. Now, technically, you could solve it. Don't write this down yet. I want to give you a little explanation on where the formula comes from, okay? If I said that's equal to x, you would change it to exponential form. And then what would you have to do? Add the log on each side. And what happens to the exponent when you do that? And so if you're solving, you divide, so it's just log 7 divided by log 5. Would you guys agree with that? That's what the change of base formula says. It's just a shortcut, so you don't have to work the whole thing out. It's just log of the big number divided by log of the small number. So this formula is the only one I won't give you. You should know it, or if you forget it, you could work it out the way I just did. So the work that I expect, you at bare minimum, I need to see you write this piece for your work. And then I want 4 decimal places, so then we plug it in our calculator. So log 7 divided by log 5. And that gives me 1.2091. All right, so you have to show me at least that one line of work with the change of base formula. If you forget the formula, work it out, and then give me the decimal. So for B, if I wanted to use the change of base formula, which one would go on top? Divided by log of 2. So that's the work I expect. We put that in, we get -3.3219.